all to my YouTube channel. This is my official YouTube channel. Today we are starting about stoichiometric calculations. This is what we are starting. So we are going to talk about all the calculations that are involved under this. This is where you get to find of the more concept, limiting reagent, percentage yield. So here we are going to start with the more concept. This is our first lesson. So now under this stoichiometric calculations, the first thing that you need to understand, you need to know how to find what we call, this is what we are calling, you need to know how to find the relative atomic, you need to know how to find the relative atomic mass. This is the first thing that you need to know. How do you calculate the relative atomic mass? So the relative atomic mass, what you need to know, maybe if a question comes in an exam where you are told to define the relative atomic mass. So the relative atomic mass, this is just the mass, this is the mass of an element. This is the mass of an element compared, so mass of an element compared to 1/12 mass of carbon-12 isotope. This is what you need to know. So whenever we are talking about the relative atomic mass, this is just the mass of an element compared to 1/12 mass of carbon-12. So the relative atomic mass, so the word atomic, we are talking about a single atom. For example, you can have sodium. So you know that this is sodium. So if a question comes and you are told to find the relative atomic mass for sodium, you know that what is the mass number for sodium? It is 23. So the relative atomic mass for sodium is what? Is 23. No units. So what you need to understand also, the other thing is that the relative atomic mass don't have any unit. These don't have any units. So let's talk of, we have magnesium. Magnesium, you know that it is what? It is 24. The mass number, it is 24. So these don't have any unit. You just need to write them like that. So these are some of the examples that we can discuss. So away from this, the other thing that you need to know, this is very simple, is called, you also need to know the relative molecular mass. So we've got the relative molecular mass. You need to know the relative molecular mass. So what is the relative molecular mass? The relative molecular mass, we've got this word, this definition are quite similar, but the difference is that here we are talking about mass of a compound. Have you seen mass of what? Mass of a compound. Here we are talking about the mass of a compound compared, we are also comparing, so mass of a compound compared to 1/12 mass of what? Of carbon-12 isotope. Carbon-12 isotope. This is what we are really talking about. So isotope, like that. So this is what we get to mean. This is the definition. So I'm giving you this summarized definition so that if they come in an exam, we are able to tell the examiner what relative molecular mass is and relative atomic mass. So relative atomic mass, you are just talking about a single atom. But here you are talking about a what? A molecule. It can be a compound. So this is what we get to talk about. So this is the mass of a compound compared to 1/12 mass of carbon-12 isotope. This is what you need to know and understand. So even this one, the relative molecular mass, don't have any units. They don't have any units. There are no units attached to this. So for example, you may talk of, we've got what? You may have sodium chloride. This is an example. So how do you find the relative molecular mass of this? What we get to do is the same one that we know, where we say here we've got what? So this is chlorine. How many atoms of chlorine? 1. So 1 times, what is the mass number for chlorine? It is what? 35.5. So what is the answer there? Then you go to this one. How many atoms are we having for sodium? It is 1. Then you say times, what is the mass number? It is 23. Where you say this is equal to, then you add, here you are going to have 35.5, here you are going to have 23. So when you add them, what number are you getting? When you add these two, what number are you able to get? 50. This is what we are getting. We are getting 58.5. So this is the what? This is the relative molecular mass. No units. Don't forget. Whenever we are talking about this, we don't need to attach units. So units should not be included whenever we are talking about this type. Units should not be included. Let us now move and talk about the other compound. So in another compound that we can talk about, we can have, so let's say maybe you've got sodium sulfate. This is how sodium sulfate is. So for you to reach this topic, you need to know how to form formulas of specific compounds. You need to know how sodium sulfate looks like. You need to know how to write the chemical formula for sodium sulfate. So how do you come up with the relative molecular mass for this one? You also do the same procedure, the same one that we know. So we know that whenever we want to calculate this one, what we are going to do is that you are going to say here, you are going to start with this one. How many atoms are you having there? You are having about 4 atoms of oxygen. So 4 times, what is the mass number for oxygen? It is what? It is 16. So you say, you go to this one. This is what? This is sulfur. How many atoms there? 1 times, what is the mass number? It is 32. This is how we get to do them. We move to the other one. This is sodium. How many atoms of sodium are we having? Just 2 times the mass number, which is 23. So we get to add here. What is 6 times 4? 16 times 4, we get 64. You move to this one. What is 1 times 32? This is 32. You move to this one. What is 2 times 23? That is 46. This is what we are going to do. So when we add here, what are we going to have when we add here? What are we having? So here, 4 plus 2, it is 6. 6 plus 6, it is 12. So 2, remainder 1. You add here, this is 13, 14. So you're going to have 14. No units. So these are the what? These are the, so what you need to know is that these are the relative molecular mass of sodium sulfate. This is how you calculate the relative molecular mass of sodium sulfate. So let's make sure we understand this part clearly. We know all the necessary points on how to calculate this. So the key thing is that these don't have the units. So you need to understand that part. These don't have the units. And this is how we get to calculate this. So we proceed and look at another type. So another thing that we are going to talk about is called the molar mass. So I'm summarizing this so that we understand each and every concept that may come in an exam. We've got the molar mass. So molar mass, what are the units? The units for molar mass, the units are what? Grams per mole. These are the units for molar mass. So each time you are talking about molar mass, you need to know that these are the what? These are the units. So now, what is molar mass? If a question comes in an exam to define molar mass, what is molar mass? Molar mass is the mass. So mass, so whenever we are talking about this, we are just talking about what? The mass of 1, so I'm going to write this, 1 mole of a substance. So 1 mole of what? Substance, like this. So what is molar mass? How do you define molar mass? Molar mass is the mass of 1 mole of a substance. This is how you need to define molar mass. So if you are given a question in an exam, then you are told to define molar mass. You just say that molar mass, this is the mass of 1 mole of a substance. Then you are done. So these ones, it is just the same as the relative molecular mass, but they are expressed in these units. These are the units that we get to express them. But we just do all the calculations that I was doing. So referring to this example, have you seen there I was talking about what? That is sodium what? Sodium sulfate. So this is sodium sulfate. So it was sodium what? Sodium sulfate. It was like this. That was sodium sulfate. So when I'm told to find the molar mass, I'm going to do the same calculations that I was doing, but since a relative molecular mass doesn't have units, but this one has got units, so I'm going to get the same one there. So it is going to be 142. Then I'm going to say grams per what? Grams per mole. So grams per mole. This is what I'm going to do. But all the calculations are the same. You just need to put all the calculations. All the calculations are the same. I don't know if you still remember what we covered under when we said sodium chloride. Sodium chloride was here. Have you seen the way I did sodium chloride? It was what? 58.5. So 58.5. So when you are told now under molar mass, if you are under molar mass, then you are told to find the molar mass of sodium chloride. So we've got sodium chloride. You are told to find the molar mass for sodium chloride. You know that it is what? 58.5. This is the relative what? Molecular mass. But since you are under the mole concept, under the molar mass, you need to say grams per what? Per mole. This is what you are going to do. So these are things that you need to put now into consideration. This is what we need to know and understand. So all these things, you need to put them into consideration. You know them, so that each and every question that will come in your exams, you won't fail to answer any question. You won't fail to answer any question. So let us look at another part now. So this is now the interesting part that we've been waiting for. People were saying we do a teaching under the mole concept. So before we talk about the mole concept, these are terms that you need to know. These are terms that you need to understand. So when you're talking about a single element, let us talk about, let's say you are talking about a single element like magnesium. Magnesium, you know that the relative atomic mass for magnesium, it is what? 24. So when you are taught to find the molar mass of magnesium, you put units. What are the units? You say the same one where we say this one is 24, relative atomic mass. But since we are talking about molar mass, we put units. What are the units? Grams per mole. This is what you just need to include. So these are terms that you need to put in place. These are terms that you need to understand. So now let us look at the actual topic now that people want, which is the mole. We talk about what a mole is. So this is now the topic that we are talking about. What is a mole? What do you understand by the term mole? What is a mole? What is a mole? So whenever we are talking about a mole, this one is very simple. We are all going to understand what I mean and what I'm talking about. So a mole is defined, whenever you hear the word a mole, one thing that should come to mind is amount of substance. Have you seen? So what is a mole? A mole is the amount. So you say this is the amount of substance. So amount of substance which contains, so this is the amount of substance which contains as many elementary. So this is elementary elementary entities. Elementary entities as. So I'm going to continue here. I'm going to say as they are in what? As they are in 12.00 grams of carbon 12 isotope. So this is what we are saying a mole is. So if you are told to define what a mole is, what we are saying is that a mole is the amount of substance which contains as many elementary entities as there are in 12 grams of carbon 12 isotope. So this is what you need to know and understand. This is the definition of a mole. So if you are told to define a mole, you can just say this is the amount of substance which contains, so the amount of substance which contains as many elementary entities as they are in what? As they are in 12 grams of carbon 12 isotope. You know what an isotope is. So each time you're talking about an isotope, maybe you've been wondering why I've been using this term isotope. So you are asking yourself, what is an isotope? So I believe we've all done isotopes. We know that an isotope, this is an element of the same compound. This is an element of the same atom which contains the same number of protons but different mass number. This is what we get to talk about. So we are talking about the same what? Same compound or same atom having same proton number but different mass number. This is what an isotope is. So now we understand what a mole is. So we know that this is the definition of a mole. This is how a mole is, and this is how you need to know and understand what a mole is. It's just the amount of substance which contains as many elementary entities as they are in 12.00 grams of carbon 12 isotope. So we've got a specific formula now that we get to use whenever we are told to calculate the number of moles in a compound. So the formula that we get to use, this is the formula. So the formula that we normally use, we just say the number of moles are equal to, so number of moles are equal to what? Mass over molar mass. This is the symbol for molar mass. You know that this one is the what? Is the mass. You know that it is the mass. Mass is in what? Mass is in grams. This one here, you know that this is the what? This is the molar mass. You know that one? That it is the what? It is the molar mass. In what? Grams per what? Grams per mole. Like this. Then this one is the mole. The units for mole are just these. Have you seen? So whenever you calculate now, the units are supposed to be in mole like that. The M there, it is the mass. Then capital letter M here represents the molar mass. So when you are told to calculate the number of moles in a compound, these are the units that we get to use. This is what we need to know and understand. So I want everyone to get this. I want everyone to understand the mole concept. So I'm making it easy so that everyone can get the concept, so that everyone can understand everything that I'm trying to say. So let us now look at an example. Maybe you look at an example, then you are going to understand what we are really talking about. So let us look at an example. So let's say you're given a question saying how many, so it's saying how many moles of potassium. I'm going to use K. This is potassium. How many moles of potassium are there? So how many moles of potassium are there? So I'm going to say how many moles of potassium are there in 3.9 grams of potassium. This is the question that you are given. So they're saying how many moles. You want to find the number of moles of potassium. How many moles of potassium are there in 3.9 grams of potassium? The K there, that is the chemical formula for potassium. So want to find the number of moles which are there in potassium. So what is the formula? The formula, you know that the formula is equal to mass over what? Over molar mass. This is the formula that we get to use. Where we say this is now equal to, number of moles is equal to, what is the mass? The mass is 3.9 grams. Over, what is the molar mass? Potassium, what is the molar mass for potassium? You get to calculate the molar mass for potassium. So what is the molar mass for potassium? You are given this on your periodic table. So it is what? It is 39. You know, you just check on the periodic table. It is what? 39. So 39 grams per what? Per mole. Don't forget. So when you divide here, you say 3.9 grams over 39 grams per mole. The grams will cancel out. You're going to remain with a mole. So when you divide here, you're going to get 0.1 mole. So this is the answer now. This is the answer that we get to talk about. This is what you need to know. Look at our example 2. So this is the example 2. In our example 2, what we are told is to calculate the molar mass of 2.5 moles. This is the question. Calculate the molar mass of 2.5 moles of a substance X weighing 100 grams. So how can you calculate this one? So the way in which you are going to calculate this one is from a formula where you know that the number of moles is equal to mass over what? Over molar mass. This is the formula. So in this question, we are taught to calculate the what? We are taught to calculate this one. Have you seen? We are taught to calculate the molar mass. So how can you calculate the molar mass? So if you cross multiply here, what you are going to have is that you are going to have the number of moles times the molar mass, which is equal to the mass there. Then you divide by the number of moles, you divide by the number of moles. Where this and that will be cancelled, then you are going to have the formula, which is what? Molar mass is equal to the mass over what? Over the number of moles. This is the formula that you are going to use. So this is the formula that we are going to use. Where we are going to say this is now equal to, what is the mass? We are given the mass that it is what? 100 grams. Over what? Over the number of moles. We are also given the number of moles, which is 2.5 moles. Like this. So when you divide there, what answer are you getting? When you divide, what answer are you getting? You get your calculator, you say 100 divided by 2.5. What is your answer? You're going to get what? You're going to get 40. Since you are calculating the molar mass, so grams per mole. Don't forget the units. So these are the units. This is how you calculate the that one. So these are simple procedures that you need to follow. These are simple stuffs you need to get whenever you want to answer this question. So now I want us to look at another example. So hope you are able to see how I'm able to calculate this. So this question is saying how many moles? So how many moles of hydrogen? I'm going to put H there. Hydrogen atoms. How many moles of hydrogen atoms does? So how many moles of hydrogen atoms does 3.2 grams of methane, which is what? CH4 contains. So contain. This is the question that we want to answer. Have you seen the way this question is? The question is saying how many moles of hydrogen atoms does 3.2 grams of methane contain? So the first thing that you need to do for you to calculate this question is to find the molar mass. Find the molar mass for methane. After you find the molar mass for methane, you calculate the number of moles. So we find the molar mass for methane. So what is the molar mass for methane? You say molar mass is equal to, so we've got methane, which is CH what? CH4. If we do the usual thing that we know, where we say we've got how many atoms there? 4 times 1, which is equal to 4. Then we go to carbon. Carbon, how many atoms? it's 1 times, what is the mass number? 12, which is equal to, like this, 12. So when you add these two, what you're going to have is 16. We're going to have 16. We're going to have what? 16 grams per mole. So when you add those two, this is what you are going to form. When you add 4 plus 12, you're going to have 16 grams per mole. This is your what? This is the molar mass. So you've calculated the molar mass. Let us now calculate the number of moles. So you say number of moles is equal to, we say mass. This is the formula. We say mass. What is the mass? 3.2 over the molar mass. What is the molar mass? The molar mass, it is what? The molar mass, it is 16. You do this 16, which is equal to, so this is equal to what? So when you say 3.2 over 16, it is equal to what? It is equal to what? 0.2. This is the answer that you are going to get. So these are the number of what? These are the number of moles of this compound. Which compound? Methane. These are the number of moles. So the question was not telling us to calculate the number of moles for methane. But what the question was saying was for us to calculate the number of moles of what? Hydrogen. So which formula do we get to use whenever we want to calculate this? So we're going to say the formula we're going to use. So the number of moles for what? For hydrogen. This is the formula that you're going to use. You say number of atoms. So the formula is what? You talk of number. Number of what? Number of atoms. So number of atoms. Number of atoms, you say multiplied by what? Multiplied by the mole. The number of moles. Multiplied by the number of moles. So you say this is now equal to, how many atoms of hydrogen are we having in this equation? This compound. How many atoms? There are 4. So you say 4 times what? Times the number of moles. So this is how we get to calculate this. Times the number of moles of the O compound. So the number of moles for the O compound is what? 0.2. We calculated this one, was that one. Then this is equal to, have you seen? This is equal to. So this is equal to what? You say 2 times 0.2. The answer that you're going to get is what? 0.8 moles. So this is your what? This is your answer. You've calculated the number of moles for hydrogen that are contained in this compound of methane, having this as its mass. Have you seen? This is how we get to calculate this. So these are terms that you need to know. These are terms that you need to understand whenever we are talking about the mole. So all these calculations are falling under the mole. All these are falling under this. So away from this, there is also another part that you need to understand. Hope you are able to understand. Hope you are able to get the concept. So make sure you put down all these things I'm putting into practice. Let's make sure we revise through them. You know how to calculate. You know how to find the molar mass. You know how to find the number of moles. You know how to calculate the mass when you are given the molar mass and the number of moles. So you just make the subject of the formula. This is how you need to do all these calculations. So I want to make this topic very simple so that we get to understand the basics. So these are the basics that will enable you to understand this topic. These are the basics that will enable you to understand this topic. So let us now look at another part. Let us look at another part. So this part that we are going to look at is called we know it, Avogadros constant. So Avogadros constant or number, just one and the same. So we need to understand what this one is. It is called the what? Avogadros number. What is the Avogadros number? How can you define Avogadros number if a question was to come in an exam? So this is just the number. So we are going to say this is just the number of particles. So just say this is the number of particles in. So the number of particles in. So this is in. The number of particles in. So I'm going to do this. The number of particles in 1 mole. The number of particles in 1 mole of a pure substance. Pure what? Pure substance. In 1 mole of a pure substance, which is what? 12 grams of 12 grams of what you've been doing. 12 grams of what? It is 12 grams of carbon. So 12 grams of what? 12 grams of carbon. You talk of carbon. Contains what? Contains as many as, I'm going to write it here, as many as, so I want you to understand this, as many as 6.02 times 10 to the power 23. That's power 23. Have you seen 23 atoms? This is what Avogadros number is. So if they ask you what is the Avogadros number, Avogadros number is the number of particles in 1 mole of a pure substance, which is 12 grams of carbon. Have you seen 12 grams of carbon? Contains as many as 6.02 times 10 to the power 23 atoms. This is what you need to know and understand. These are terms that you need to know and understand whenever we are talking about that. So we need to make sure that we understand that one clearly and very well. So this means that 1 mole, when we are talking about 1 mole, so 1 mole is equivalent to what? 1 mole is equivalent to 6.02 times 10 to the power 23 what? 23 atoms. This is what the definition is really talking about. So 1 mole is equivalent to this. So when I say 1 mole, let's say 1 mole of what? 1 mole of calcium. So 1 mole of calcium, it is having the number of moles or the mass, which is what? 40 grams. Have you seen? This is the mass number, which is equal to what? It is equivalent to 6.02 times 10 to the power what? To the power 23. This is what you need to know and understand. We can talk of iron. You know that 1 iron is equivalent to this number of particles. So here 1 mole of calcium was equal to, you know that 1 mole of calcium contains 40 grams. 40 grams is the mass number, you know it. This is the Avogadros number. You can talk of 1 mole of an atom. 1 mole of an atom is equivalent to this same number of atoms. 1 mole of a molecule is equivalent to this same number of molecules. 1 mole of electrons, it is equivalent to this same number of electrons. So this is what, so when you say 1 mole, have you seen 1 mole of a molecule? 1 mole of a molecule. This is a molecule. So 1 mole of a molecule is equivalent to what? Is equivalent to 6.02 times 10 to the power 23 what? Molecules. This is what I meant. Have you seen the way we are dealing with the mole concept? This is what you need to know and understand. 1 mole of anything is equivalent to this number of particles. So these are terms that you need to know. These are terms that you need to understand under the mole concept. So we are here to break down the mole concept so that we understand each and every question that may try to come in an exam. So let us look at one example. Let us look at one example under this question we are given. This is our example 1. The question is saying, if 1 mole of carbon is 12 grams, calculate the mass of 1 atom of carbon. How can you calculate this one? So you know that 6.02 times 10 to the power 23. So the power 23 atoms. To the power 23 atoms is equivalent this one is equivalent to what? So it is equivalent to what? The first term here, which they are saying what? You say it is equivalent to 12 grams. Now, one atom, whenever we're talking about now, one atom is equivalent to what? Is equivalent to X. Want to calculate the mass. So this is what you need to do. 6.02 times 10 to the power 23 atoms is equal to what? Is equal to 12 grams of one atom of carbon 12. Then one atom is equal to X. Here when you cross multiply this will be cancelled. Which means that what you are going to do here, what you are going to form is that this one will go with that one. So you are going to have, you cross multiply, in other words. When you cross multiply, you are going to have 6.02 times 10 to the power 23, like that. Then you include the X here, which is equal to 1 times 12. It is what? It is 12. This is what you need to do. You want to find the X, so you divide both sides by 6.02 times 10 to the power 23. Even here you divide by 6.02 times 10 to the power 28, like this, or power 23. So this cancelled. Then you are going to have what? X, which is equal to. So when you divide here, what answer are you going to get? So when you divide there, what answer are you going to get? So you get your calculator, then you say 12 divide 6.02 times 10 to the power what? 23. What answer are you going to get? What answer are we going to get there? What answer are we going to get? So when we divide 12, divide by, I say 6.02 times 10 to the power what? Power 23. What answer are we going to get? The answer that you are going to get will be, this is the answer that is there. This is the answer that I found. It is 1.993. So which means I can just write it like this. Hope you are able to follow. 1.99 times 10 to the power negative 23. This is the answer that I've found. So then I just put what? Grams. So this is the what? This is the mass of one atom of carbon 12. So these are procedures that you need to get. This is an understanding that you need to have under this. So these are what you need to get. These are what you need to understand whenever you want to calculate any question related to this. These are just procedures that we need to follow. You equate this, you equate to that. So let's make sure we understand this, we get the necessary concept. You get all the concept that is required. So now, the other thing that we are going to talk about, let me do this. The other thing that we are going to talk about is, now we know the calculations from equations. More to more calculations. So more to more calculations. This is what we are going to talk about. More to more calculations. How can you go about the more to more calculations? So this is very important. This is where you get to compare the moles this side and the moles this other side using a balanced chemical equation. So make sure you understand this. Make sure you get this point. You first thing, you write the chemical equation. After writing the chemical equation, you balance it. So you need to make sure that it is balanced. So let us look at an example under this. So we say you are given equation. This is equation here. It is saying how many moles of calcium, how many moles of chlorine are required to react 2.5 moles of calcium to produce calcium chloride. This is the equation. How many moles of chlorine are required to react 2.5 moles of calcium to produce calcium chloride? So what is the first thing you need to do? The first thing which I've told you is to write a chemical equation. So we are saying that calcium is reacting with chlorine. So chlorine is a diatomic atom. You know, it must have a 2 there. So when these two reacts together, they are going to form calcium chloride, which will be like this. So now you are using mole to mole calculations. So if you check the mole ratio here, this is already balanced. We've got 2 chlorine this side and the 2 chlorine this side. 1 calcium this side, 1 calcium this other side. So this is already balanced. So how can you go about this question? What you're going to do is that how many moles of calcium this side? We've got 1 mole of what? Calcium. 1 mole of calcium. Then how many moles of chlorine this side? How many moles? 1. So you say 1 mole of what? You say 1 mole of what? Chlorine. This is what you're going to do. Then calcium, how many moles? We've got 2.5 moles. Equivalent to what? X, which we don't know. Then you do what? You cross multiply. So x here times the 1 there, you are going to have what? You are going to have x, which is equal to 1 times 2.5. It is 2.5 moles of what? Of chlorine, like that. So that's how you need to do it. Have you seen the way I've answered this one? This is how you need to answer it. This is how you need to go about this question. This is how the calculations are supposed to be done. So this is how you need to go about this one here. So now, answer that we found. So this is how you need to go about this one. Hope you've understood all the concepts that I've done here. So first thing, you write the equation. This is the equation, you write it. Then you check how many moles here. There is 1 here. The number of moles are just 1, because that is the same one that we've used to do it, to balance. Have you seen? That is how you need to go about it now. So now, let us look at the example 2. We focus on the other example. Let us look at example 2. Example 2, under mole to mole calculations. So it is saying how many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose. So this is the other question that we want to answer. How can we go about this question? How can we answer it? You write an equation. So glucose is undergoing complete combustion, which means that it is burning in oxygen. So you know that glucose, it is like this. This is how we write glucose. You do this. Plus what? Plus the oxygen, we do it like this. To produce what? What is being produced? It is what? Carbon dioxide. So you say carbon dioxide is being produced plus what? Plus water. This is what is being produced, like this. So when you balance it, you know that we are going to have a 6 there. We are also going to have a 6 here and a 6 there. Then it is what? It is balanced. So we always use a balanced equation. We always need to use a balanced what? A balanced equation. So now you want to find the moles of what? The question is saying how many moles of carbon dioxide. So you want to find the moles of carbon dioxide. So how can you find the moles of carbon dioxide? Where is carbon dioxide? Carbon dioxide is here. Where you are given what? You are given glucose. Having what? 2 moles. So glucose here, it is having how many moles? Which we've used to balance. Which we've used to balance. It is what? 1 mole. So 1 mole, it is here to glucose. Then this other one, carbon dioxide, we're having 6 what? 6 moles. There's a 6 there which we've used to balance. Then how many moles are given for glucose now? It is 2. In the question, we are given 2 moles, equivalent to what? Equivalent to x. This is what you are going to do. From here now, you do what? You cross multiply. So this and that will be cancelled. 1 times x, it is x, which is equal to 2 times 6. It is 12 what? 12 moles of carbon dioxide. So this is how you need to do these calculations. This is how you need to do them. So these are the calculations you need to understand. So you are using what? Mole to mole calculations. Getting the moles this side and the moles the other side. This is what you need to do. So these are some of the examples that we can talk about when we are dealing with mole to mole calculations. we also have the other part which is called, we need to talk about mole to mass calculations. How can we go about the mole to mass calculations? The other part that we need to talk about. So this other part, it is what? It is the mole to mass calculations. So this is an example which I've written here saying how many grams of oxygen are required to react with 0.3 moles of aluminium to produce aluminium oxide. So this is a question. What is the first thing you need to do? The first thing you need to do, don't forget, we are dealing with mole to mass. So we get the moles this side, we compare them to the mass this other side. So we are given what? What are we given? We are given aluminium. So aluminium is reacting with what? So aluminium plus oxygen like this. Then it is equivalent to what? You say aluminium to like this. So we balance. The first thing is to do what? The first thing is to balance. How do you balance that? You put a 2 here, you put a 4 there, then you come and put a 3 here, which means that it is what? It is now balanced. Then you compare. You are given what? You are given this one. What are you given? You are given this one here. What is this one? You are given the 4 moles here of aluminium. Then you want to find for oxygen. So what is the mole for aluminium? That is the 4. The 4 that is given. So you say 4 moles, you equate it to the what? Number of grams, this part here. So this is oxygen. How do you calculate the relative here? The relative molecular mass. You are going to find 32. But the more there, it is having a 3 there. Have you seen you do this? Maybe if you've forgotten what we were doing, we are saying it is like this. And a 3. Have you seen? So you say this is 2. You say 2 times what? 16. You are going to get what? 32. You are going to get your 32. 32 times, it is appearing how many times? 3 times. 32 times 3. Then you find your answer as what? 96. So 96 is the mass, man. It is the mass that we are going to use. So we say here we put what? 96 grams. How many moles this side? The moles that were given in the question for aluminium, 0.3. 0.3 what? 0.3 moles. Is equivalent to what? X. You don't know. This is how you do it. So this and that will be cancelled. Have you seen the way I've done? I've compared mole to grams here. Mole to mass. So you cross multiply. X times 4, it is 4x. Which is equal to. So it is equal to what? You say 0.3 times 96. Like that. This is what you are going to do. You divide both sides by 4. You divide both sides by 4. So this and that cancelled. So x is equal to, your x is now equal to what? So when you multiply here, the answer that you must find when you say 0.3 times 96, you see that answer. Then you say divide by 4. So we are getting what? We are getting 7.2 grams of what? Of oxygen. So you do this for what? For oxygen. This is what we are doing. So this is how we've calculated the what? The question was saying how many grams of oxygen are required. So you know, when you're given the moles, then you are taught to find the grams. Or you are given the grams, you are taught to find the moles. Just know that you are dealing with a mole to mass calculation type of equation. So this is how you need to go about this. This is how you need to understand these questions. So I'm showing you the easiest way in which you can go about these questions. Let us look at the last part. We focus on the last part now, which is mass to mass calculation. So mass to mass calculation. The last one is a mass to mass calculations. So mass to mass calculations. This is the last one that we are going to discuss. Mass to mass calculations. So how you are taught to calculate mass to mass calculations. So how can you go about this one? So this is an example. So here I'm just giving out examples. You see how questions usually come in an exam. So it is saying calculate the mass of calcium chloride produced when 40 grams of calcium carbonate reacts with hydrogen chloride. Some people call this as hydrochloric acid. So write the equation. The equation is saying what? Produced when what? Calcium carbonate reacts with hydrochloric acid. So this is what we are getting. We are saying when calcium carbonate. So calcium carbonate, we are given the calcium carbonate plus. So calcium carbonate plus what? Plus this one here. So what is produced when these two react? What is going to produce? In the question we are given that calcium chloride is going to be produced. Calcium chloride will be produced. So calcium chloride will be produced. This one and that one will be, this will go with that one. Then we have what? We are going to have also carbon dioxide. Carbon dioxide will be produced plus what? Plus water. So this is what we are going to have. This is what we are going to have. Have you seen? So this is what we are going to form. This is what we are going to. So, but our key interest, when you look at this, this is already balanced. So whenever we are talking about mass to mass calculations, when you check through this whole equation, you try to do what? We try to balance it. So when you want to balance such an equation, you need to put a 2 here. So when you put a 2 here, then the equation is balanced. Have you seen? It is what? Balanced. So we calculate. So what do we want to calculate here? Want to calculate the mass of what? Calcium what? Calcium chloride. Calcium chloride, the mass of calcium chloride. Okay, what are we given? The mass of calcium carbonate. We are given the mass of what? Calcium carbonate. So mass to mass, you calculate the mass of that one. Relative molecular mass. Do you remember? Yeah. So hope you are able to remember. You start doing 3 times 16, 1 times 12, then we've got the 40 there for calcium. So you get your calculator, you say, so 40 plus 12 plus 3 times 16, what are we getting? It is 100. So you do the same calculation. So you get this one. So 100 what? 100 grams. This is for what? For calcium carbonate. You do this. You equate it to what? To this one. So this one, it is giving you what? This is calcium, it is 40 there. You say plus. So 40 plus, that is 12 times, 2 times 35.5. What are we going to get? We're going to get 111, like that. That is for what? Grams of what? Calcium what? Calcium chloride. So I'm just showing you how this one is for that one. So equate this. Then you are given 40 for calcium carbonate here. You say 40, you're given 40 grams. Then this one here is the one you want to calculate. You put X there. You know that here, these are going to be cancelled. Have you seen? Then you say 1 times 100. What are you going to get? You're going to get what? 100x, which is equal to. You say 111 times 40. Times what? Times 40. This is what you're going to do. What are you going to get? You are going to get 4,440. This is what you are going to get. You divide both sides by 100. You also divide both sides by 100. What answer are you going to get? So definitely x will be equal to, when you divide by 100 both sides, you are going to get 44.4. So 44.4 grams of what now? What were you calculating? Calcium chloride. So just say calcium chloride, just like that. So these are the calculations that you need to put into consideration. These are the calculations that we need to do. Have you seen? So now let me give you just a few questions that you are going to practice. Let me give you some questions that you need to practice. This is your assignment. This is your assignment. Hope you are able to see these questions. This is your assignment. The first question is saying, what mass of calcium metal reacts with 9.0 grams of water? The second question is saying, how many moles of ammonia can be produced from 8 moles of nitrogen gas? These are the questions that I want you to practice. These are the questions that I want you to answer. So let's make sure that we answer these questions. We practice through them. So let's make sure we answer these. we practice through these questions. These are the questions that you need to answer. So let's make sure we answer these. Hope you are able to see these questions. You can pause the video, you copy them and understand them. So if you are looking for tuitions in science, or you want to be added to the group, you just text me on WhatsApp on this line. This is my number. So this is what you get to do. Have you seen? This is what you get to do. This is my number. So make sure you call me on this. You WhatsApp me on WhatsApp 0971 066747. This is my number. Thank you so much. Don't forget to like the video. Don't forget to subscribe to this YouTube channel and comment.